okay? And let's look at number 2. What do you think the answer to A is? On 2A. We're looking at problem 2A. What would the monthly phone bill be? What? $30. Yeah, $30. Remember, Unit 1 is all about functions. And functions can be weird, and this is a little bit of a weird function we're going to look at right now. Number 2A, $30. How about B?
30.
How much?
35.
50. Be $50 because you, every additional, is that gigabyte? Costs you $10. So it doesn't matter whether you use the whole gigabyte or not, you're gonna pay that extra $10. If you go over 3, then you're paying for 4. So $50. What would a picture of that look like? Could you graph that relationship? What would that look like?
Yeah, 2 gigabytes would be at 30.
So this would be at 30. So a closed dot there at 30. So if I use 2, I pay 30. What if I use 1? I still pay 30. What if I don't use any? I still pay 30? So don't I pay 30 for that whole strip right there? So 1/2, if I use 1/2, I still pay 30. If I use 1.5, I pay 30. But then what happens after that? What happens if I use 3? Then I'm doing 40. And in fact, aren't I doing 40 for anything between 2 and 3? So I'm gonna put an open dot there at 2, because at 2, I pay $30. But anything bigger than 2, I pay 40. And then how about 4? 4 costs me 50. In fact, anything more than 3 is gonna cost me 50, right? Up to 4, and so on. Would you agree with that? Now, one way of expressing that would be with a piecewise function. Would you agree that's a piecewise function? Graphed in pieces. So one way of expressing it would be with a piecewise function. So I'll just say C of X. So C of X, you said, was going to be $30 if what? If X was between 0 and 2? Does that look okay to everybody? And then the next piece would be $40 if what? X is between 2 and 3. And then we'll do the last piece we graph, that would be $50 if X is between 3 and 4.
If you had to write the equation for like something like that, like that just keeps going. Like when would you just stop after the third one every time, or like?
Well, if I'm doing a piecewise function, which is what this little section is about, yeah, that's enough to give me an idea. This is kind of like what we call the greatest integer function. So we could maybe write an equation with that, notation. I'm not going to do that, we're just gonna focus on that. But you're right, it does just keep going. Till you run out of money. All right, backside. Pizza Palace is offering a promotion. The cost of a pizza as a function of time measured in days since February 10th can be described by this function. All right, so look at it, figure out what's going on here. T is measured in days since February 10th. Okay. What would a pizza cost on Valentine's Day?
$11.
I heard 7 and 11. What do the rest of you think? 11? Why would it be 11? Because Valentine's Day is 4 days after February 10th. And so I'm gonna let T be 4, which goes in that middle line of the piecewise function, so $11. On what day should you go to Pizza Palace to get the best deal? February 11th, 12th, 13th, or 10th? 10th, 11th, 12th, or 13th? Because you're only gonna pay $7 on those days? Find C of 9 and C of 8, subtract them, and interpret the result in the context of this problem. All right, take a second and do that. Find C of 9 minus C of 8. What'd you get? 3? What does that mean? It's gonna cost $3 more on the 19th than it did on the 18th. Yep, went up $3 overnight. What is the significance of the domain restriction 0 to 28? Notice in the piecewise function, your smallest t is 0, your biggest t is 28. Why is that? Charlie?
Only 28 days in the month of February.
There are 28 days in the month of February, but this is a little odd because how is t measured? Not in days from the beginning of February, but from the 10th. So isn't this problem actually taking us into March? So I'm not exactly sure what that significance is, because we're only measuring after February 10th. But you're right, Charlie, that would be the first instinct.
Yeah, right.
But then we go back and look at what T stands for. All right, what's the graph look like? Can you sketch it? Can somebody come up and do it on the board? I'll set up a grid for you. like these hash marks are, 14 of them down there, I think. No volunteers? Thank you, Lillian.
Ooh, I think we-
Nicely done. What do the rest of you think? Is that what yours looks like? Yep. Anybody have a question for William on that? That looks good.
I had like steps in there. Because it wasn't going up.
You know what, Violet, you might be right, because C is money, right? So T, and T is being measured in, yeah, I think you're right. So I think that's gonna impact all of these, because
The bottom one and the top one, I think are fine. I think it's just.
no, I don't think so. I think because the very same argument you were making, and that is at 1.5 days, but we don't have 1.5 days, it's the days after February 10th. So those are integer values. So the first day, the second day. So even these would be, they're all in a row, but there'd be a solid dot at 1 and 2 and 3. And then these would be, whatever they are, 3 to 8, so there's 3, and then 4 would be 11, and 5 would be, 12, and 6, and 7, and 8. Do you guys see Violet's point? I think it's a good one. That the price of the pizza isn't going up in cents. That you are 1 day after February 10th, or you are 2 days after February 10th. You're not 1.5 days after February 10th. So X and Y are both integer values. And so instead of plotting them as lines, we're gonna plot them as dots in the same shape that William had, just no connections.
Why
Charlie?
is that dot starting at 10? That open circle now, why is that 10?
Where should it be?
I'm not sure. That
Yes, because look at the middle line of your function. So if T could be 3, Y or C would be 10. But T can't be 3, so we put a little open dot there. Now, since we're not connecting, technically you don't need that because we've got a dot right here for 3. But I think it's okay to leave it, but since we're not connecting them, it isn't essential. Because we're going straight from 3 to 4. Yeah, great observation, Violet, good job.
Wait, so on like the lines, like the straight, I get why it's the dots on the diagonal. Why is it dots on the like straight lines? Because in the price 18, even if it's like 8.5 days or like 10.5 days or whatever.
Well, it is, but T, that's not the way T is measured. T is measured in the days after February 10th. So you are 1 day after February 10th, or you are 2 days after February 10th. You don't go into the pizza shop and say, hey, it's been 3.5 days since February 10th. No, you're either 3 days or 4 days after February 10th. Yeah. So this is like a practical problem, not a theoretical problem. Good. Okay. All right. Next page. Do females live longer than males? All right. So we're looking at specific data points. Let D of T represent the average difference in life expectancy T years after 1940. So in other words, let's make sure we're interpreting the graph right. In 1940, it looks like women lived 3 years longer than men. Would you agree with that? Is that what this thing's saying to me? And then in 1950, it looks like women lived about 4 years longer than men, and so on. So are we good on that? Okay. So why is a quadratic model a reasonable model?
war.
Okay, so you're explaining why we have that bump. Light goes up. What shape is that? That's a parabola. So why is a quadratic model a good model to have? Because it's shaped like a parabola. Yep. Now Charlie explained why it's shaped that way, which is a great thing to talk about. All right. Let D of T for somebody. Okay. What is the minimum number of data points you need to determine the values of A, B, and C? Talked about this yesterday. 3. We need 3 data points. Why do we need 3 data points? Because there's 3 variables in a quadratic equation, A, B, and C. So we need 3 ordered pairs, 1 for each variable. Guys, we talked about that yesterday. We did that problem yesterday. Now, we could all do this and get slightly different, but let's do this together. Number 3, what is the value of C in our equation, and how do you know? So our equation is going to be AT squared plus BT plus C. You have a picture in front of you. What is your C going to be? 3. Why is our C 3? Because C is the y-intercept. And it looks like the y-intercept is 3. Why is that the y-intercept? Because the y-intercept is what happens when x is 0, right? So if x is 0, according to the picture, I gotta be at 3. So C is 3. Choose 2 other data points and write them as ordered pairs. All right, I need your help with this. Find a couple of ordered pairs. mean, obviously they're not gonna be perfect.
1950 and 4.
1950 and 4.
Yeah.
Now, we're not gonna say 1950
10.
though, we're gonna say 10 and 4. I can live with that, can you? Alright, let's get one more.
35.
What?
25.
20 and 5. So let's look, that would be 1960. That's pretty close to 5, right? Okay, this isn't gonna be perfect, we all understand that, right? So, let's go. So what do? We already know C is 3, that we use the point 0, 3 was our other point. We use that, gave us C. So now we'll plug these in. So 4 equals 100A, are you following along? How did I get 100? 10 squared plus 10B. I put 100 in, or excuse me, I put 10 in for my T's, and then plus 3. And then 5 equals what? 400A plus 20B plus 3. All right, let's solve it. I make a mistake.
This is 4.
Yeah.
I think the points can't be in a straight line.
Yeah, because what just happened? What just happened?
0 equals 0.
A came out to be 0, and that can't be. So let's pick another point. Yeah, we gotta pick another point, because actually along with 0 and 3, all 3 of my points are in a straight line, aren't they? So we need to fix that. So let's get rid of that one and let's pick another one. How about, and we get one on the other side,
What about like 35, 6?
35, 6.
I don't know if that'll work.
I don't know, where's 35? 35 would be
It's the
1975.
approximate.
6, yeah. That is not in line with these, so let's try that one. So that was my first equation, is that still okay? And then 6 equals, oh no, what's 35 squared? So 1, 2, 2, 5.
Oh, yeah.
All right, let's see if that works out any better. Well, I like my other numbers a lot better. But. Yeah. No, that's all right. You guys better not be letting me do this by myself. I need some help here. Oh, no, wait a minute, that's not 6. Oh, yeah, that was 3, yeah, that was right. But actually, yeah, actually, what?
And there,
Well, it's negative, that's good. Why am I excited? Because I got a negative, because it opens down. I'm not very excited, because now I have to find B. Is anybody else doing this? Did I make an arithmetic mistake, or is this coming out? Is this what you got? I got B to be 37/350.
No, your first one's right. I put it into like stats and then calculated it. Quadratic.
Coming out right? Yeah. And so, I don't know, what did B come out to be?
I got the same thing.
Okay, perfect. All right, so my equation is negative this t squared plus that t plus 3. All right, so hang on to that. Write and solve a system of equations. All right, that's what we just did. Will everyone have the same model? No, we did because we used the same points, but if you were all doing it on your own, they'd be a little different. Use your model to predict the average difference in life expectancy in 1983. So what would we do if we're finding the average or the difference in 1983? Plug in 43 into that. I got 6.489 years. Anybody else get that? Now, let's look at our picture. 1983, it looks like it would actually be a little bit less than that, but that's okay, our model's not perfect anymore. How close or far off was it from reality? Well, what is it in reality? 5.8 years. So we're off a little bit, half a year or so. Do you think our model will overestimate or underestimate the average difference in life expectancy in 2010?
Underestimate. It's gonna keep going.
Yeah. Did you hear what she said? If you look at the picture, the actual data, what happens at the end of the parabola? Does it keep going down? Not at the very end. What does it seem to be doing? Kind of leveling off a little bit? What is that gonna do? That's gonna keep on going down, so it's probably going to underestimate, would be my guess. All right, now turn the page. What's another way we could have done this problem? You have told me that it's a parabola. Has this parabola been shifted? Yeah, because a normal parabola looks like this. What's happened to yours? its vertex is not the origin. Its vertex is approximately, what did we say? 35, 6? So what would that look like? Y equals x minus 35 squared plus 6. Doesn't that move your parabola right 35 and up 6? Now, there's a number out here in front. I don't know what it is. I know it's negative. I don't know what it is. How could I find that number? Pick another one of my points and plug it in and figure it out. Alright, so what point do you want to use? I want to use 0.3. Is that what that was?
Yeah.
Now, is that gonna give me exactly the same equation? No. But that's because I'm not using exactly the right points. But that would be another option. That would be another way of writing that equation. Okay? All right, let's look at the next page. Check your understanding. Let's spend a couple minutes. You're getting kind of bored, so let's spend a couple minutes with your partner, see if you can hash out 1, 2, and 3, and then we'll talk about it. One, 2, and 3. And then move on to the next review.
What did we just do that? Y equals x plus 5 become x minus 2 all plus 30 again. Is that what I got?
Okay, did you have a thought about number one? Anybody have a thought about number one? How'd you start? I didn't say this, but I hope you didn't just type those points in on your calculator and do a cubic progression. Is that what you did? Nope, did it by hand, good. How would you do it by hand? What was your thought process? Come on, this is an easy one.
Four variables and you have 4 points.
So you could, absolutely, you could do that. You could also remember that if it has zeros at -5, then it has a factor at x plus 5. And it has a factor at x plus 1. And it has a factor at x minus 2. You follow what I'm saying? Those would give me the x-intercepts. Now, what it doesn't tell me is, all this says is, we have these x-intercepts, and then I've got some kind of cubic function that's connecting those points, but I don't know what direction it's going, I don't know how high it's going. There is a coefficient out here that's controlling that. And to find that coefficient, I have to plug in a point, and the point that they gave me is the y-intercept at 30, which means I have the point 0, 30. So if I put a 30 in here and zeros in for all of my x's, it looks like that missing coefficient is -3. So my polynomial looks like this. Now, it doesn't say that it has to be in standard form. If it had to be in standard form, I'd have to FOIL all that out, but that right there answers the question. That's a cubic polynomial that meets all the qualifications. Now, Violet's idea was a cubic polynomial is going to look like this. How many variables? How many points do you need? How many do you have? So you could plug in, for example, if I plugged in -5, 0, I put 0 here and then plug in -5. And there's one of my equations. And I can do the same thing for the other points. Now, that one's gonna make it easy for me because that one's gonna tell me that D is 30. But I'm still gonna have 3 equations to solve. But that will work, 100%, that will work. All right, did you get anywhere with number 2? Write an equation for T of V, which is the time it will take to complete this year's mailing if there are V volunteers. You guys are killing me. No ideas at all? William, you're always good for an idea. What's your thought?
Was it just linear? That's like kind of what I thought.
It is totally linear.
So then I just did T of V equals X times 4/7.
Well, let's use V.
Yeah.
But 4/7's V?
Yeah.
That's it. Where'd the 4/7s come from?
Hours, it's open the amount of volunteers from last year.
Yeah, so we know that last year we had 7 volunteers and it took them 4 hours. So didn't each volunteer do 4/7 of the job? Is that right? So if each volunteer is gonna do 4/7 of the job, then 4/7 times the number of volunteers will tell me how long it's gonna take. All right, did you get anywhere, I hesitate to ask, with number 3? Mr. Braun?
What do you want me to just say the answers?
Well, I want you to tell me what you did.
Okay.
Tell us what you did.
I put it in my calculator, and translated all the times to a decimal.
Okay, good. That's the key there. Did you notice that T has to be in minutes? And when you time somebody and it's 13:16, that's 13 minutes and 16 seconds. So he converted all those to decimals. Okay? All right, so then what? Oh, and then just put them all in.
Yeah,
Okay.
and then finding the average rate of change, I did T of 48 minus T of 0, which translated to 12.583 minus 13.267 over 48, which was negative 0.0205 minutes a year. And then
Wait, type that in again, Kyle. Quinn, Ron, type that in again.
Okay.
At least I didn't call you Jay. Right? That's his dad, who I also taught.
Oh yeah, I got a different answer.
Yeah, do you get negative .014?
Yeah.
Yeah, yeah,
It's the
so,
same
okay.
as from the homework, isn't it?
What?
Isn't it the same as the homework?
Oh, was it?
I think so.
Oh, could be. Oh, well, that's okay. Now we're doing it anyway. Okay, so you just did your average rate of change formula. Perfect. And then how did you do the last part?
I haven't typed all that stuff in yet, but if I typed it all in, then I would stack, calc, and then
What kind of regression will you do you think?
is it quadratic or is it linear?
Well, if it were quadratic, then that means as the years go on, the time goes up and down or down and up. Is that what's happening here? As the years go on, the time is just decreasing, right? So of the options that we have available to us right now, it probably is linear. And what will that negative .014 look like, or what will it correspond to when you do your regression?
What do you mean?
That'll be the slope.
Yeah.
Now, it won't be exactly because the other points are taken into account, but it's gonna be close to the slope. That's exactly right. Good job. Anybody have a question about that? I gotta give you something here.
For the y, like at the end of the linear thing, would it just be the 13.267 cents when at the start?
It should be, but because the points don't all lie in a perfect line, it's gonna come close to that, but it doesn't work out to be that. If you were writing your own line, he's already found the overall slope, the average rate of change, so negative .016 x or t, and then plus that 13.267 number. That would be your approximation. The calculator's gonna do a little bit better approximation, because it's gonna take all the points into account, not just first and last.
So like we should just start calculating.
Yeah. To do part B, that would be a regression in the calculator, yeah. But you're exactly right, Celeste, we could do that without a calculator. Wouldn't be quite as good, but we could do it. All right, we got a little more review in the packet here, and then I got a bigger review here, another review that I want to start on. My thought is, I'll see you again on Thursday, or sometime Monday, I don't know, we'll see how Thursday goes. But either Monday or Tuesday, we'll be having a little quiz to wrap up huge one. But I wanted to get this in your hand so that you could start looking through it. So there's no problem. We need to do, and I know today's work seems a little odd, but remember, you never know what problems are in your way, and you have to be able to deal with all of them. So that's what we hopefully did today. We've got some step functions or piecewise functions,